Good morning, good afternoon, good evening, wherever you are, and welcome back to another episode of The Ways We Move, the podcast that highlights innovative mobility solutions and the people behind them. My name is Nicholas Zart, and I am your host on this podcast where we really go out of our way to uncover some of the most innovative mobility solutions out there. And today, I certainly have one that fits that title very well. Jared Semik has a long career in aerospace and aviation, also a Marine veteran, and he brings to the table something that is not always found or found as often as we would need to find in advanced air mobility or in any other form of innovative mobility solutions. So he's working on a project that would yield an aircraft that can fly thousands of miles, roughly 8,000 miles, using hydrogen, but creating electricity for electric propulsion, basically. Now, when I first heard that, I thought, another hopeful one because there are a lot of projects like that out there. But what changed my mind and what made me continue to talk to him was the fact that he was extremely pragmatic how he was approaching this. First of all, he's not using an off-the-shelf solution. He's working with NASA, and he went as far as taking one of NASA's most promising technology, but that still wasn't working fully well, decompose it completely, break it down to its bare essentials, and then bringing it back together into a coherent platform. But the one thing that he does a little bit differently than other companies do is that he's not patchworking it all together and then looking at the efficiency of it all, the coherence of it all. He's doing it as he's really breaking down the components. How do you use first principle thinking? How do you make everything coherent? How do you make everything efficient? And it's a very subtle change from what we have seen up until now, but it also begs the one question that I've been asking for well over a decade is talking to these founders, these CEOs, these people who are changing the way that we will travel and be mobile tomorrow is you walked away from a big corporations because you felt shackled with a business model, a financial model, you know, business as usual kind of model to embrace this paradigm shift of electric propulsion, which in and of itself is so different from internal combustion engines. So you embrace this newer technology, but yet at some point or another, you bring in the old business model of how you structure your startup, the old business model of how you approach the financial institutions to fund you. And there's no easy solutions for that, right? Because that's how 99.9% of our societies work. But in order to make full sense of a new technology and a new business, you also have to adopt a new business model. And of course, that means also new financial models. And this is where the sticking point is today. So, anyway, we're going to talk a little bit about that with Jared. And he cannot fully say what he's working on because they're still in stealth mode. But I want you to pay attention to the way they're approaching this, and they're not just using the idea of an eVTOL in a vertiport world. They're really talking about how do we eke out so much efficiency that now we can use something and exponentially have more energy coming out of it than how we traditionally think about these things. I hope you will enjoy this podcast. Please like and subscribe. It means a lot to us. It helps us a lot. And of course, share with other people who may be interested in understanding a little bit more about what is happening out there, what kind of innovative mobility solutions are going on. And you might even see that today's podcast, although we do talk about aviation, is something that could work in the maritime world and why not even in the railroad industry. So look forward to your comments and please let us know what you think. And we'll see you next week with some interesting news. I'm launching a business intelligence platform because after 20 years, I've seen a lot of what can work and what doesn't always work. We'll see you next week again. Well, Jared, thank you very much for being with us on The Ways We Move. This is the podcast where we talk about innovative mobility solutions and the people behind them. And really, I don't think anybody fits that title better than you. So give us a little bit about who is Jared and give us a little bit about your background.
Yeah, thanks for the invite. I'm glad to be here. So I'm Jared Semik. I'm the founder and CEO of Eternium Corporation. We're split into two divisions, the aerospace and hydrogen side. I'm a 8-year veteran of um, defense aviation. So I was an aviation Marine for 5 years, three deployments, and 3 years in the Army Reserves.
Wow, thank you for your service.
Yeah, it's a pleasure. I'm also a 20-year veteran of research and development in the aerospace industry. I'm responsible for, I would say, somewhere in the neighborhoods of about 20 proprietary technologies. I have two personal patents myself and a contributor to any number of others, and mostly in the direction of where we're taking Eternium Aerospace. That's a little bit about, that's a snapshot of me. There's many more bits, but yeah.
It's a good one because you really laid it out really well for now we can talk about what you guys are doing. And I have to say before we do that, there are a lot of wild and funky projects out there, and some eventually make it, some don't. But the one thing that we know for sure is that eventually we'll get there, right? We all grew up on Star Trek. We're watching, from a phone, from a tablet, all the things that they were thinking about before. And so I've heard a lot of people wanting to go your route, but I've seen that some of them sometimes go too much in the research part of it and forget what they're really trying to do, or on the more theoretical side of things, and of course miss out a few spots. And so far, all of our conversations have shown me that you're sort of striking that middle road. You're not getting bogged down too much into only looking at the technology. You're keeping the big picture alive. So tell us a little bit about what are you guys doing? What need are you answering that people may or may not know that they have?
Well, so Eternium's trying to tackle the hydrogen and aviation space. There's quite a few players. Everybody's has their specific ideas. When I set out to solve this problem in my engineering career, I basically started just asking questions because it's sort of the impetus of how I operate um, as a STEM professional, just in general, is I'm very inquisitive. I think the thing that usually stands me out is kind of what Einstein says. I'm just incessantly curious. And I really sat there, and it was one of those moments where it was just, sitting in my cubicle of all places in my little my walled prison. And I was kind of asking. I was like, I've been a lover of aviations. I mean, I've been in my entire professional career. I started in and around aviation and about 16 years old when my mom gives me this discovery flight, and I get hooked on aviation. So, I started flying. I did air crew, and so I mean this whole thing, and I've had a love for aviation. Um, and I started asking the question, like, where are we going next? What would it take? Everybody's really kind of electrifying. What would it take to really kind of get into that space? And I think the one thing that I really sought to answer, I don't really feel a lot of the other organizations that are trying to tackle this issue are really sort of asking. I don't think they're really driving towards that direction. They may be indirectly, but I don't see a whole lot of evidence that that is their mission statement. And the mission statement for Eternium is, how do we get to electrification with usable adjacency of performance? So, to clarify that, that means,
Wow.
how do I create a non-petroleum based aircraft that can fly and carry the same weight over the same distances with, the same performance characteristics or superior? How do we do that? And Eternium, basically, when I started the business, when I mean, pre Eternium's existence, was really just kind of walking through every one of those elements and basically
Mm.
answering them one by one from a technical perspective. And I feel like I'm a hybrid thinker in the sense, the blue collar background with the military experience of, fixing and flying aircraft.
Well
Kind of
said.
it gives me this, kind of, it does give me that pragmatic experience,
Yeah,
perspective. It
that balance.
Exactly. And fixing cars, fixing jets, fixing, everything else. I understand we have to make things, and we can sit around and speculate all day, but in the end, how are we going to manufacture this? What kind of capabilities are we going to give to humanity? And then only then, after that, as a business, how do we monetize it? You have to be
Mm.
mindful of, what are the capability statements? So the idea was, okay, once we started running into the same problems that I feel everybody else is running into, I started understanding that patchwork doesn't work. We need to
Hmm.
find synergies. I know that's a buzzword, but we really need to actively find the synergies in the system, in the physics. And I started knocking out things. The one of my patents is our dual rotor high temperature superconductive motor. Ultra high torque density. I mean, that those things are going to be necessary to get us to where we need to
Oh,
be.
yes.
But I started realizing that individual component improvements wasn't going to actually get cut the mustard. So I think what I ended up doing at that point was kind of taking it in a different direction and seeing how these systems relate to each other and how can we extract the maximum amount of energy with what we have available, what modalities. And it really has just been kind of this iterative process of macro improvements to individual components driven by full systems development and full systems architectural holism. And I think that's really kind of the driving statement, the driving spirit behind Eternium. Um,
Yep.
and it's also sort of the driving mission statement of Eternium is to say, okay, how are we going to actually compete with the incumbent? Because this is the thing that I've really decided that it has become the talking point that I need to rest on is I can create a motor or I can
Hmm.
create say a new fuel cell or a new Brayton system, or I can create, I could slap all this in a blended wing body. But the market will not exist for those components if the platform doesn't exist, and the platform won't exist if it's not competitive with the incumbent technology. If I'm putting a 500-mile range aircraft that can't carry anything, and I'm trying to put that up against, say, a Gulfstream 650 that can fly 8,000-mile range, which one am I going to buy? Why? Because it's green? Right.
No.
Yeah. And I think a lot of it has to, I think what we're missing in the industry is a lot of that real hard realism is just this. I mean, you should see people's faces when I say this at conferences.
Yes. Oh, yes, I can imagine. So, and this is, I mean, what the point you're making is so subtle, and I think it might be lost for a lot of people because everybody thinks that they are doing a holistic work when they develop either an eVTOL, an eSTOL, an eCTOL, whatever, a drone. But you're doing it in a much more pragmatic way, which means that you're actually saving time on R&D because you're
Mm,
really thinking it way, way, way before. Whereas you're right, a lot of companies do a lot of patchwork, right? And then after that, once they have a sort of a mosaic, they go, all right, how do we make this efficient, right? You're taking that step way before, which ultimately means that you might get there faster than most other people, or at least faster than we think of. Because when we think about doing what you're doing, pretty much everybody is will agree that it is 50 years into the future.
yeah.
But if you do it the way you do it, and this is the futurist in me, right? This is what I've seen for the last 20 years repeatedly. This is where a lot of companies fail, is just they're a little too pragmatic, but maybe not a little holistic enough. You might be doing this in maybe half the time or even less, actually. Who knows?
Yeah,
Well, that's what I.
I would agree with that to a degree. The issue is
Okay.
the barrier to entry of that is the inertia that exists in the mindset that we have in most technology industries.
Oh,
You've
yes.
got
Oh, yes.
this shift that had happened in the 90s to sort of software as a service. I feel investors and a lot of the foundational support networks for startups, for tech startups, have kind of gotten largely lazy in their funding models in the sense that, they want very quick turnarounds on investment.
Yes.
And they have very low risk tolerance. They have very low tolerance for long runways that are necessary. They just want it out to the market. And as an economist, as a business person, I understand the return on investment. I understand.
Of course.
I don't want to vent, capital assets into the ether and not get any sort of return in a reasonable amount of time. So I understand the fiscal side of it. It's that we have to, and this is what I'm trying to deconstruct and sort of realign, is this idea that the holism doesn't necessarily exist solely in the technical space. It exists also in the fiscal side, the funding and resources in development, and also sort of the business structure side. And I think that is a big issue that we run into. And you make the comment of, I think you're going to get there faster. And my only pushback is, I was asked very early on when I started doing this, you get into accelerators and, various different cohorts, and they
Mm.
ask you, all those boilerplate questions where, what do you see the biggest barrier to success? And much to everyone's chagrin, I would always say humans mindset. The human mindset
Yep.
and
Yep.
our tribalistic, socialistic way of doing things that we've always done. And I know it's cliche, but
No, it's not.
it's the reality that we exist in is that, things I can't completely rail against it because it works. When I'm upset about the fact that we don't de-risk by system, we don't de-risk by holistically, we de-risk by the component. The reason why no one wants to depart from that is because it still works to a high enough percentage of success that it sort of glosses over the fact that we can't have the next step of really nice things in tech without thinking holistically. Everything that we really want as a society is on the other side of holistic thinking. You look at social programs, you look at politics, you look at technology, you look at the development of all these things. I mean, look at all the things that have sort of fallen flat on their face, and kind of gotten a black eye. You look at solar and wind, and you look at
Yep.
the fact that, we de-risked that by the component. And we made some amazing wind turbines. We made some amazing solar panels and solar fields and, concentrated solar thermal. The problem is that we never really thought of it as a system. We didn't deploy it as a system. We didn't integrate it as a system. We didn't understand all of these things that needed to take place. And then when we actually deployed them in a patchwork, we just sort of, we're going to slap this into the grid and hope for the best. And the issue that we ran into is the fact that it failed because we didn't think of it as a system. We thought that everything was just a module.
Exactly. A
And all,
module on top of it.
yeah, and all these modules don't just plug and play.
Nope.
I'm watching some of these conversations being had, presentations, various commentaries about some of the OEMs. They think that we're going to arrive at success for electrification of aviation and marine vessels by modularity. And modularity is really good for optimization at a for a budgetary perspective
Yeah.
but not particularly when we're trying to completely change the paradigm. You can't shoehorn, you know,
No, and to your point, modularity works when you have a platform that you've been using for a very long time, internal combustion engines, everything. Yes, in that case, it makes a lot of sense. But then when you're going to a new, whether it's an energy platform, it's a propulsion platform, whatever, then you need the same paradigm shift that needs to happen at the business level, at the financial level. You're hitting a point I've been making for well over a decade, talking to all of these CEOs, these founders, all of these people. And the question I've been asking them is, okay, so let me get this straight. You left XYZ, think big international corporation company. You could have retired with millions of dollars in your pocket to embrace a fundamentally different means of mobility, but you're looking for money the same way that those big companies are.
yep.
You structure the business exactly the same way that the same thing that you ran away from, you're bringing into that. How do you expect that to work? And now we're getting right back to the definition of insanity is repeating the same things, expecting different results. Well, you can't. If you embrace electric mobility, whereas 99.9% of everything we do is internal combustion engines, then you need to change everything radically, fundamentally. So this is what I liked about you because this is something I've been looking out for the last 20 years, and not a lot of companies. Well, I shouldn't say that. A lot of companies understand that, but they're either they cannot do it or they don't know how to do it. And we've talked about this. There are solutions. It's just I don't know where it breaks, so I don't know what makes you so different than others. But I wanted to talk a little bit about what you are trying to do now. What is the answer that you're trying to solve here, the sticking point that you're trying to solve here inside of our mobility industry, or our new mobility industry, I should say?
Um, it's we all understand, electrification to be, largely initially driven by, um, sort of the reduction of, carbon emissions and, everything that we've kind of beat, the dead horse that we've beaten to death, again and again and again. Um, but I think being a military veteran, having deployed overseas a few times, and you're looking at these, large, what do they call them? These I can't remember what they actually call the emerging conflicts. Is they're like block conflicts or like large power peer-to-peer conflicts. A lot of
Gotcha.
what's happening geopolitically is, I mean, time immemorial.
Yeah.
It has been driven
Yep.
largely by,
Yep.
resource management and resource
Yep.
allocation and the economics of the needs of man. And I am a self-sufficientist at the core. I
I
believe.
love it. Self-sufficientist. I love that term.
I think I just kind of spontaneously coined that.
I love it. We're gonna keep it.
I think, in order for everybody to play well in the sandbox, I agree that there should be a modicum of interdependence, because we can't do everything. But I
Of
think this
course.
hyper specialization, I think, doesn't work really well when we're considering sort of the human condition. I think the humans largely are tribal. I think they're
Yes.
largely selfish. I think they're largely a lot of things, on top of all the good things that we can be.
Of
But,
course.
but at
Of
our
course.
core, you have to understand that, people want the prosperity, and there's oftentimes conflict when those parties meet at the resources. So when I'm thinking of what additional thing that drives me, I think it's actually probably 90% at this point is what drives me is sort of fuel and energy independence. I know it's another buzzword, democratization. But
Yep.
when you're thinking about these regional conflicts over, say, like oil or any other energy resources, any of the other high demand resources, I have a bit of a problem with the fact, the geopolitics are basically always centered around that, and I want to do something about it. And I think electrification of aviation is at least one of the many tentacles of this hydra. Um, you know, is
Yes.
is if we can sort of get ourselves out of this space of
Yes.
regionally extracted energy, and then on this
Yes.
entire
Hello.
infrastructure. Yep, it's like this entire infrastructure of refinement, of delivery, pipeline, and distribution. And you can do something like localized. So, one of the things that we're working on is
Boom.
a localized, a high temperature, high pressure alkaline electrolysis system in the same spirit of, say, Tesla. When Tesla Motors created their vehicles, they understood the infrastructure also has to be simultaneously developed and
Of course.
standardized. And they knew, I mean, Elon Musk and his cohort, understood that in order for this to proliferate, these are the things that we're going to have to do, and we can't just rely on the energy production system to do it for us. We have to create the chicken and the egg at the exact same time. And a lot of that to me ends up becoming a vision of sort of this um, more democratized. There's obviously going to be stakeholders. There's obviously going to be people that are, they're going to own it and control it, et cetera, et cetera. But it becomes sort of decentralized. It becomes a little bit easier for us to play, well in the sandbox when everybody's able to make their own fuel and use it in, these now new fuel compatible vehicles. I think it at least contributes. I'm not so delusional to think that, the technology that we're developing is going to somehow, save the world. But I think it at least contributes to some of the issues that we have. And I think that is largely I think it's largely the power of electrification is in the
Yep.
sense that when you electrify, you can diversify the energy input sources. So wherever you're getting it from the grid, whatever makes
That's true.
electricity can power electric
That's
vehicles.
true.
And to a certain degree, the same as with hydrogen. I mean, it's not the exact same as just an input with batteries, because it's a chemoelectric energy storage system. You essentially kind of have the same thing with hydrogen, except for instead of it being internally contained um, and non-exhausted, you um, you're storing it in, obviously in a different form. And there are some advantages to it. There are obviously some disadvantages, but when
Of
you
course.
when you add all of these elements together, and I know we're kind of getting really deep into the weeds of, like, how
Hmm.
all of this stuff overlaps. It's, when you're looking at it from a system standpoint, you're now kind of, venturing into availability and ease of production. And, if you're creating it locally, you're eliminating some of the issues with, infrastructure in terms of transportation and storage and, et cetera, et cetera. So I don't know, that got really long-winded, but that's.
Yeah, no, no, but you that's such a great point that you've been making. That's what got me started in 2006 on electric mobility is look, it's super efficient. It's way more efficient than an internal combustion engine. And then the other thing too was that it was, 5 years after 9/11. Obviously, this is made at home. This is safe local energy that we can really localize to. Of course, now that's a big problem for these big companies that like to make domestic products. But it was just a wonderful idea, and it's true that I think we've seen a lot of localized energy solutions, but they've never really made it. I think the one person, speaking of hydrogen, because hydrogen, by the way, is always the same thing. You love it or you hate it, and most of the time for all the wrong reasons, right?
Yeah.
But the one person who actually did make some sense of how to use hydrogen in aviation was Val Mikdakov at Zero Avia.
Yeah.
I'm not saying his solution is perfect, right? But he had something that he pat down, and he said, all these regional airports, what do they have? A lot of space that's unused, right? You can create energy there. You
Yep.
can create electricity, hydrogen, whatever you want to do, a temporary storage solution as hydrogen. And that was for me the beginning of, oh, okay, I get it. Because in the EV industry, in the automotive industry, it made no sense, right? Cars are everywhere, the distances are too big. And a gas station instead of a city does not have that much space to make hydrogen, let alone a lot of people wanting 10,000 pounds per square inch, hydrogen tanks right under where they live. Yeah, not really the thing that they want
Yeah.
to. However, with aviation, now you do have that, and I think this is where you're going with that one. So tell us a little bit about why did you choose, excuse me, hydrogen and not some other form of energy or storage energy,
Um, I mean, anyone that's been in
energy
this,
storage?
anybody that's been in this space really kind of knows that I mean, the issue is always specific energy and energy density. I mean, when you're looking at
Yep,
batteries, you're talking about 400, what is it, 400 kilowatt hours per
kilowatt
kilogram,
hours. If yeah,
you
if
know,
that's a good point. Yeah,
and um, well, it's 400 watt hours per kilogram versus 31.2 uh, kilowatt hours. So I mean, you're talking about 31,000 watt hours versus 400
yes,
watt hours per kilogram.
yes,
So I mean, you have really good specific energy, and but of course you have a slight advantage over batteries when you come to energy density. So volumetrically, it's not nearly as good. I think that's why we've really sort of stuck with petroleum for a while because it's almost a one-to-one specific energy to volumetric energy density ratio, which kind of makes it very ideal. But for aviation, you end up getting a lot of different advantages. I mean, you have that mass reduction per volume. So if you can figure out how to utilize, more of the aircraft volume, so like the wing volume, the fuselage volume, in sort of a distributed method of storing the hydrogen, you can carry more energy. More energy equals more range, especially when you have this kind of a mass discount, if you will versus both batteries and petroleum. That ended up lending itself into a lot of the, you almost can't avoid. So when you ask a question, it's a single pointed question. I think this is what's interesting about holism is that you ask a single pointed question and there's, you can answer it simply, and you can say, well, we used it because of energy density, et cetera, et cetera, et cetera. And, if you look at a lot of the successful vehicles that are out there, you look at like the Toyota Mirai that set the record of like 845 miles on a single 5.6 kilogram fill, obviously under good conditions, et cetera.
yes,
But you can look at that and you can say, okay, well, there's something there. So, um, and then you look at some of the issues, with respect to the mass of batteries, blah, 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 and you arrive at this thing. Okay, well, this is going to be our energy storage. This is going to be our energy storage modality. But the thing is then it starts opening up. It branches off the tree. And then all of a sudden you
yes,
start having these things that, well, okay, well, it's great. It's great in mass, but it's terrible in volume. So how do we, you know, how,
exactly.
how do we mitigate some of these things? Okay, so
And then the next question that follows after this is, are we talking about liquid hydrogen or gaseous hydrogen? Which route did you choose? Because again, pros and cons. Gas is going to have a lot less weight than the liquid, but liquid still would eke out a little bit more than petroleum. So how did you make that decision? And what was the decision, by the way?
so we went with liquid, mostly because compression of gas is too it's too energetic. I think hydrogen terrifies a lot of people. I think compressed hydrogen terrifies even more people. Obviously, cryogenic fuels, it sounds a little exotic, but we've been using it since, I mean, I think the Nazis were using it in the V2 rocket. I mean, we've been using it since
Exactly.
Werner von Braun created, all of our rockets that
Yep.
we use to go to the moon and, into
Yep.
space, et
Yep.
cetera. I mean, everything's been using liquid hydrogen forever. So from a technological perspective, we have a tremendous knowledge base on, its utilization. I think it's a little exotic for the general public. There is some volatility, but here's the thing. Everything that stores energy has volatility. You puncture a battery. Yep,
Petroleum, anything, batteries,
yep,
everything can explode. You just got to be careful about it. And the funny thing about it is we were able to master fire on a log, right? We mastered everything
yeah,
in the end. So if you're just going to cower every time there's a problem, then yeah, please step out of the way. Find solutions. The tagline of my company is there are more solutions than obstacles. You just
yeah.
got to find them and you will find them.
Well,
Sorry.
and the thing is that, I think that's another kind of hallmark trait of my personality. You ask, kind of like really sort of bringing into the fore, kind of what are the elements that create this sort of pragmatic perspective? And I think a lot of it is a lack of risk aversion. I'm a calculated risk taker. So I've been in the air since, the early professional career. Aviation.
Exactly.
I'm a rock climber. I'm a mountaineer. I scuba dive. I ride motorcycles. I've raced dirt bikes. I was a
Yep.
skydiver years back, and you can look at that and say, this person has no regard for their safety, et cetera, et cetera. But if anybody that actually knows me knows
No.
how calculated I am in terms of risk, I sort of get this snicker because I'm very careful with personal protective equipment. I'm sort of known for if I do anything, I'm sanding with an orbital sander. I put on my I put on my glasses, I put on my respirator, I put on, I usually have hearing protection. And I think a lot of that is, it's not because, there's a level of anal retentiveness. I think I've been around so many very energetic things, very loud, the amount of times I've injured myself, I have hearing loss from the military
Yep.
being around jet engines. You have all
Yep.
these things and it starts to kind of enlighten you. I mean, that's
Yes.
sort of the thing about, life experience is that you could read it in a book, but the life experience will make it an indelible truth to you. And I've essentially kind of learned these things. And you realize that, the concept of risk doesn't make any sense to me. It's really to that point to me because the people are always talking about risk. Oh, risk, 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 risk. And it's like, well, to me, I just, like you said, I see problems to be solved. Um, and I,
Yep.
and obviously, yes, there is some risk reduction. I don't go headlong into things. I don't go, I'm not the level of climber as Alex Honnold, so I'm not just going to go to El Capitan and just say, hey, I'm just going to start free climbing this. Um,
It's a mountain.
yeah, right. It's like, well, I'm a climber. This is someone's done it, so obviously it's possible. So I think I'm going to do it. No, it doesn't work that way. You know. So there's obviously some risk in the calculation. It's just to me, I think that's sort of what courage is required to go move into the spaces that we're moving into, and I think that's sort of where we exist is when you were talking about a lot of these tech founders have left these large, corporations, these, OEMs, the primes, et cetera, and they've started their own business, and they get into the situation where, we need funding, we need to, and they're
Boom.
structuring the company the exact same way, and they're getting funded the same way. And I think the issue is that I think people encounter the pushback and it terrifies them. They're like, okay, well, I'm going to lose my income source. I'm not going to be successful. I have to play nice in the sandbox. I don't really have that. So I think a lot of this is I have a very strong level of patience for everything, people and situations and just life in general. And I think what that gives me, and I think that's what gives Eternium, is this sort of patient perspective of, okay, if say VCs or the funding bodies in the federal government and they're releasing these solicitations and you propose to them and you keep getting rejected, et cetera, et cetera. And the issue with it is because of the holism. They're like, you are the scope's too big for us. We want you to de-risk at the component level. And then, there's no opportunity to fire back at them and say, hey, listen, you can throw millions and millions of dollars into a really nice motor. It will have zero market. If you're making an aviation based or marine vehicle based motor, it will have zero market because those things are not competitive. The platform's not competitive equals no market equals no market for the components that are being created for it. So we're just throwing a bunch of money into something that's never going to
Yep.
happen because we're not actually thinking of something holistically. And
Yep.
I think it
Yep.
sort of
Yep.
runs into that, and I think that's now folding all that back onto the way I operate with Eternium is essentially now I take this, long suffering, this patience, and saying, listen, we need to now sort of pivot into kind of raising awareness of the fact that this is not going to happen unless this happens. And unless we completely change the way we do things, there is any number of hardware based technologies that will not materialize. There will
Yep.
not be a critical mass established to the point where we can actually create a new economy of these techs if
Yep.
we don't create the entire system for it. And if we don't integrate that
Absolutely.
into a system that is also being thoughtfully driven holistically to also integrate those
Yes.
systems. And unfortunately, what's happening is that we have this sort of mindset that it'll happen over X amount of years. Like, oh, this is just what happens. People will learn the
Well,
lessons.
it's one part of the equation. Yes, it's true, but you need to put the work into it and the thinking before you even put the work into it, so on and so forth.
Yeah, and some of it is, I had this conversation with the guys at NASA, and I got some pushback, and they said, why are you trying to do everything? And I said, well, we're not trying to do absolutely everything. We're just trying to do the actual key components that lend themselves to the key subsystems, et cetera, et cetera. We have identified 9 overlaps of energy and mechanics that are, they're dual purpose. They're also dual use, and we're reclaiming a lot of that energy, et cetera, et cetera. That's how you're going to get it done. That's how you're going to get 8,000-mile range aircraft like ours versus a 500-mile range, which is basically a, Frankenstein shoehorn model, a tech that was, okay, just throw an electric motor into it and then just throw a fuel cell into it. And then, well, it's hydrogen. And that's essentially kind of what's happening, a little bit more technical than that. But of course,
Of course, yeah.
you know,
Yeah, I think you said it well. It's not a question of doing everything. It's a question of giving it the right foundations
mm,
and making sure that foundation is sustainable for everything else that you put on top of it instead of, like you said before, patchwork. And then after that, we look at the coherence of it all. No, you can't do that. It doesn't really work this way unless you are still back in the internal combustion engine era. Then that's fine because
yeah,
we already have a platform. That's fine. It
yeah.
works really well with it. So you started hinting at some numbers that I'm sure a lot of people who are listeners or watchers will want to hear a little bit more about it. How much can you say about what you're working on right now to give our listeners and watchers, some I want to know more about this and follow you.
Well, so the aircraft set point we're driving towards accomplishing is first and foremost transatlantic. So the ability to fly from New York to Paris or London nonstop, completely electrified, completely zero emission. When we started running the first order Bouquet equations from most of our modeling and some of our lab simulation and some of our actual lab testing of components. We put all that together and we made a virtual model. We started breaching 5,000 miles, and the more we started getting more realistic with what the capabilities are, it started driving up to about the highest estimates were I thought were absurd, but they, no matter how many knockdowns we put into some of the individual components and subsystems, we were still getting somewhere around 8,000-mile range. And this is this is obviously dry. So this is something, you're carrying the payload of, a couple of people. We're not PAX driven, so this is going to be obviously cargo. The airframe itself, we're looking at max payload of a little bit under 20,000 pounds, somewhere around the sweet spot of about 15,000-pound payload.
Wow.
Um, It's a 105-foot wingspan, blended wing body in the nature of the B2 B-21 stealth.
Gotcha.
It's not the MIT, what is it, X-47
Yeah.
derived blended wing body everyone's working on. Mostly because of lack of wing volume. We're less concerned about the overall max optimization of aerodynamic efficiency and more about kind of hitting that sweet spot of wing.
Sweet spot.
Yep. So for us, we gained wing volume, and we're also working on a conformal wing cryogenic wing tank. So we're, instead of having a large centralized cryogenic tank in the tube and wing that pretty much everyone's kind of working on, is we're going to be using um,
Uh,
the
yes,
wings
the wing
as wing tanks like they are
as a
currently.
as a wind tank, which is what we should be getting into by now anyway. So tell us, what can you tell us as far as the actual propulsion system? Because we know that you're using hydrogen, we know that you're using electric motors.
Yep.
Most people at this point are going to assume some sort of fuel cell system. What can you tell us without? And I know you shook your head when I said that. I was like, intriguing. What do you mean? What can you tell us so far? Because by the way, you're still in stealth, more or less in stealth mode, right?
Yep.
So we want to give just enough information, but obviously not everything. So that, well, anyway, you answer that question first.
Yeah, so we're not fuel cell based. We were until a conversation that I had with Roger Dyson from NASA. He lobbed over this concept that they have the Straighten. It's a Stirling acoustic Brayton closed Brayton system. And we adapted it. So we essentially we, like everything in the aircraft, we completely exploded it down to we deconstructed it down to the principles. So the form factor that NASA's been working on, we've completely deconstructed that, and we've extracted some of the principles that are in it, and then we overlaid some things that NASA's not using. So ours is not a Straighten, it's a Creighton, it's a cryogenic Brayton. So this is where those overlaps start coming in. So we use the cryogenic thermal condition of the fuel for dual use. Brayton systems are driven by as hot as you can get and as cold as you can get, and that gives you a good Carnot efficiency. So without using fuel cells, because of their mass, volume, and
Yeah.
cost and et cetera, we actually found that we can get a 60% reduction in mass and volume per megawatt out when you use something
Wow.
like a Straighten. So when you use a closed Brayton.
Can you get? I'm not very familiar actually with what a straighten device looks like. Can you give us a 52,000 foot view of it so that our listeners and watchers? Because yeah, I mean you're right. We are all thinking in terms of either generator, turbine, or fuel cell. So this is totally different.
Yeah, it looks like a plumber's dream. It's essentially a 4 foot cube, and you get about a megawatt out of it. NASA's they're doing the research on it steadily. This is Roger Dyson's technology, but
Interesting.
they're running into some issues with some of the heat transfer characteristics. A lot of what they
I
ran
would
into is
assume.
what we've essentially solved and what we're
I would
currently
assume the
working. So,
heat transfer always a problem.
yep.
Yes.
So a lot of it is, how do we integrate and improve the heat exchangers, because the massive recuperators and closed Brayton systems are an issue. So how do we integrate all of that? How do we use certain geometries to improve the physics, the molecular kinetics of the fluid, the working fluid? Not going to get into the weeds. I mean, I could talk about this
No.
stuff for hours,
No.
but a lot of it is just going back to, you're asking how do we power this? It is obviously an electrified system, so we use hydrogen in combustion to provide heat, and that heat you know is used to heat up the working fluid of a closed Brayton combined cycle Brayton system, and that produces our electricity, so our electric current, electric power for the entire aircraft. So that's obviously payload,
Oh.
auxiliary ancillary systems like flight controls, avionics, et cetera, but also the propulsion bus. So the propulsion bus, talking about multiple megawatts. So at 105-foot wingspan, the same aircraft is our full size architecture operates north of 4 megawatts. So it's not big. It's not really
Yeah,
big,
it's not big, but
but it's
it's efficient. It's good.
yeah. And the idea is each one of these individual components, they have their own increases in efficiency and power density. And then you have a lot of these overlaps. So geometric overlap for volume storage of liquid hydrogen. And then you use the cryogenic state to improve the efficiency of your energy conversion. And you also use that for cooling. So we use the cold state, the cryogenic cold state, and everything down to combustion, and then we take the high thermal state and we roll that back recuperate that back into the aircraft. So we use that for leading edge anti-ice. We use that for cabin HVAC. We use that
Of
for the
course. Of
improving,
course.
the reclamation of it is used to improving the efficiency of the Creighton system. So, and that's kind of, and then when you actually look at the individual components, the high temperature superconductive motor, it's cooled by the fuel, not directly, because we don't want a hydrogen embrittlement in the motor itself, and we also don't want
Yeah.
because motors come with, I mean, if you have a quench condition in YBCO tape, you could have a spark condition, which can, if you have the right mixture, and of course, hydrogen being pretty volatile at a low percentage of fuel air.
Yep. Yep.
I wanted to avoid that condition, and we
Yep.
also didn't want to have to worry about the embrittlement issues and the thermal shock associated with 20K liquid hydrogen fuel. So we ended up going with just liquid nitrogen, and that is cooled through a small loop, small recuperated loop using the thermal state. And then we also use the expansion exergy. So a lot of people crying about the use of liquid hydrogen because the liquefaction system adds a certain input in terms of energy and cost. And when you use a fuel cell, you have to warm up the hydrogen in order to be able to use it because you
Of
can't.
course.
As far as I know, I don't think there's any PEM or solid oxide fuel cells that can directly use cryogenic hydrogen.
Hmm.
So what we used
Yep.
is we use that a phase change exergy. We also use that and we harvest
And
that
you
for,
recoup.
yep. So
Yeah.
we use
So
that
you're
for,
hypermiling.
yeah. I mean, essentially and that is really kind of the tail of the tape. I mean, that's what we do with the aircraft. That's what we're also doing with the, what we call the Emperor scale, the modular portable nuclear reactor based, supercritical alkaline electrolysis and liquefaction system. Say that 10 times fast. Is a lot of this folding of energies, exergies, and mechanics. Um, and my, this going back to what I was saying about NASA's pushback. Why are you trying to do all this at the same time? I said, well, here's the issue. And this is kind of one of the main points I always want to make with everybody is critical mass is time and sociology related. So when you're talking about something like the use of hydrogen, people have only so much tolerance of failure until they throw their hands up and say, this is never going to happen.
Yep.
So I'm not a hype driven person. I don't like to drive hype. I like to drive pragmatism. I like to drive real data. I like to say, okay, is this possible or is this not possible? I studied all the people that failed. I mean, I'm a close student of the Theranos debacle, and it's one of the reasons why we're stealth. I don't want to go into the ecosystem and say, hey, we can do this if we are not
Yep.
able to prove that the feasibility, at least mathematically, is possible or something close. But where I'm going with this is critical mass is time related and a sort of like a market psychology related. So if we think that we're going to let an ecosystem of primes and OEMs and established, players and even startups really kind of develop this technology the way we've always sort of done it, piece by piece, unfortunately, what's going to happen is you're going to get a lot of these failures. You're going to get somebody that's not going to deliver anything remotely resembling performance parity to the incumbent, and then the general population, which includes, the sovereign wealth funds, the VCs, the angels, the president of the United States who put it in his skinny budget, basically said this is a waste of money to be funding electrification of aviation. Once you convince people that this is not going to work because we didn't go
That's
full
it.
pull, the
That's it.
funding dries up
It's
and then
easier
it
to do.
it never reaches critical mass. And we're running into
It's
that with a
easier
bunch
to
of
do.
different things. I mean, you're running with
Yep.
hydrogen in general is because we keep dithering and no one has the spine really to kind of say, we need to do this all at the same time. Let's all get on the same
Yep.
sheet of music. Let's all be clean sheet. We only have to do this once. That's really
That's it.
the operative
And
component.
stop trying to adopt old things into a different type of technology. It
Yeah,
just doesn't work, guys. Okay, and I
yeah.
think that's exactly, yeah, yeah. So, just one more question before we ask a little bit more about you personally. But when do you see the light at the end of the tunnel? I was going
Woof.
to say, but when do you? Yeah, exactly. When do you expect to actually have either a flying prototype or a conceptual framework that you can introduce to the public and say, no, we thought of this, we thought of this, we thought of this, we thought of that.
Well, I mean, the conceptual framework is already in existence. The models exist. The feasibility studies have been done. The architecture of the aircraft, the majority of the components and subsystems
Hmm.
are, are reaching a certain level of maturity, at least
Good.
in the lab. I know everyone sort of cringes. You're like, oh, you haven't made anything. You haven't, no MVPs. Well, the problem is this is a long, arduous process. And if you want to get it done fast, you do it like everybody has done before. If you want to get it done right and you actually want to succeed, you have to play the long game. And the long game
Yep.
oftentimes means that there is a lot of dead time because you have to now disengage what you're doing from a technical perspective. And then you have to re-engage sort of the mindset and mentality of the entire community. And then you have to kind of get everyone on board. This is, why I keep driving this conversation in the direction that I keep going is that until we get people convinced that this is the only way it's going to happen, this is going to be years and years and years. I would say to answer the question, I would
Yep.
say that all depends on the success
Yep.
of that narrative building.
Yeah. And I think you said it really well. It's not a technological breakthrough that you're working through right now, but it's also a human thinking
Yeah.
breakthrough, and that can take however long it takes.
Generations.
But I I'll have to tell you one thing, and this is something that I'm have to my shameless plug into this is so I do a business intelligence site, and I'll tell you something. This year we're going to see a lot of interesting movements that will definitely shake up the tree, especially the AAM tree.
Mm,
And I think it should give you enough of an open door and crack on the door so that you can say, "Great, are you guys tired of doing this? How about we look at this? Blah blah blah." So I think the way that things are going right now, there's a lot of panic. There's a lot of, oh my gosh, we're not going to make it the next 3 to 4 years with the financial models that we have right now. Investors are worn out. Simply put, we just don't have the platform
yeah.
the financial platform, the business model platform to do what we're trying to do right now. Technology, yes, I think we can make it. Well, I can make a brick spin fast enough to act like a wheel if that's not a problem, right? But I think that you're right. It is the mind frame that needs to change around that. So I'm thinking about what's going to happen the next 6 months or so might actually give you that little hump, that push forward to bend some minds around. Yeah, we're bending minds around.
Well, there is some momentum, and
Yeah.
I have personally I pivoted a little bit in some of my personal efforts as head of the company. So, we're very confident in the technical side, the business structure, et cetera, et cetera, building the co-development partnerships and creating this consortium that is, Eternium. Now I've sort of pivoted into more public speaking.
Good.
And a lot of this is, until I stop hearing I've never heard that. I've never heard it said like that before. Until I stop hearing that, I'm going to continue on.
Yep.
I think most of it is
Good point.
because one of the biggest value, propositions of my experience personally has been I've made all the mistakes. I really learned from everybody else's mistakes. That's another key thing. I can completely avoid it just by looking at everyone else and saying, okay, that's
Yes, absolutely.
let's
That's
not
why
do
it
that.
sucks to be number one or number two or number three. You want to be way behind.
Yeah.
Yeah, I agree. So for new things at least. Yeah.
Well, and that's the thing is that being able to share some of the insight from kind of the method that I think, just in general. I'm obviously a holistic thinker by nature. I love both the 50,000 foot view. I also love the nanoscopic view.
Yep.
I love
Yep.
everything in
Yep.
between,
Agreed.
and I
Agreed.
usually see it in simultaneity. So
Yes.
being able to and the talent really exists as being able to sort of take all of that I can see, and if I have a long enough timeline, it's very difficult to do it in a presentation's length because there's so
Yep.
many elements to it that cannot be dismissed. You can't, that's the unfortunate part is everyone wants everything compressed because we all have 30-second attention spans. Is there are some things that you really have to flesh out. This is the reason why. And all these conversations that I get into with fellow CEOs and stakeholders, they always push back with the same boilerplate. They say, well, why don't you do this? And the lowest common denominator, this is what you need to focus on the least effort, et cetera, et cetera. I said, that's fine. I understand that. I get the mentality. This isn't my first rodeo. However, there's the reason here. All of these in this sequence are the reason why we have to do it this way. And it took me about 2.5 hours in a conversation with the folks at NASA, Glenn. It took about 2.5 hours, and then I finally hit them with,
Boom.
if we wait for the industry that doesn't communicate amongst itself to somehow find their way to this holism, we're going to be waiting longer than the window that opens in critical mass, and we will fail, we will lose the opportunity for humanity to think that this is feasible, and it'll either take us another 100 years to get to that point, or we can do it all at the same time and prove that this is how we do it. We accomplish it just once, and then everyone else can copy and
That's
optimize.
it.
And and he basically kind of stepped back. He said, "Oh, you're right," because he had a deep knowledge of the way the way deep tech works, and the fact that there are
Right.
some things, and this, I know this from our conversations, there are some things that you can just kind of piecemeal. And those are the
Of
things that get
course.
funded and they get to the market and everyone makes money, and that's why we think that the system works. Then there are then other things where humanity's trying to transition into this other space that now we have to deconstruct the entire thing, break it down to first principles, and say, okay, what
Yep.
can we replace in this now with our new material science, our new understanding of the
Platform.
principles, and how do we now reconstruct this into something
Exactly.
slightly different?
And that's the heavy work that a lot of people are not willing to get into
Yeah,
because it would take longer time. And how do you explain that to an investor? And how do you remind an investor
yeah,
that this is aviation? This is not 6 months down the road
yeah.
or even 3 years down the road. It's a decade into that. Jared, tell us a little bit about, tell our listeners and viewers, what would you like them to walk away from with our talk today? And by the way, you're welcome to come back and continue talking about this, but what would you like people to walk away from with our talk or talk today? Excuse me.
I would definitely the centralized theme is really what I want everyone to kind of walk away with. A lot of this is, it's not about Jared, it's not about Eternium, it's not about any of these elements that are on the exterior that you're seeing. So a lot of it is a change in mindset, it's a change in the spirit of thinking, is the enlightenment into the space that exists, that is, in order to have this next phase of humanity in general. It's not even just technology.
Yep.
Technology is one element of this big ecosystem of humanity. And in order to get to that next step, like, I think I feel like we're all just kind of on the edge of that cliff. And we all want it, but we don't seem to know how to get it. And we're all arguing amongst ourselves about how is this going to be accomplished. And you're essentially, what you have is trying to put new wine into old wineskins. And
Yes, it's true.
and you have to get rid of the old wine. You need new wineskins because you're going to break the wineskins. You're going to ruin the wine. And the issue is that's what needs to be raised in terms of awareness and understanding, is this idea that everything that we want is on the other side of good holism and good systems thinking. And I think Eternium represents less the aircraft and the Emperor scale system and the hydrogen ecosystem, and it represents more sort of holism of engineering, holism of philosophy. I mean, that's part of the book that I've
Yep.
been, kicking around in writing. Is a it's a compilation of a lot of the sort of stoic thoughts of that sort of mindset of thinking. And
Yep.
a lot of people get in this like weird space where, I think it, therefore it's right. But one of the other facets of my personality is that I beat every single thing that I hold to be true. I beat it to death. So if
Yep.
I've
As you
arrived at a
should.
conclusion, oftentimes it comes, obviously, and it comes with a sort of an uncertainty. So I'm very pragmatic, both in my holding of truth, is that nothing is ever really definitively true. There's always variability in a lot of it. So you understand that the way I see something isn't this is right. I look at it in terms of this is variably in this range. So there's a spectrum of whatever. And I look in terms of everything is in terms of spectrum. So until we can start looking at everything in terms of and not just either or, we're not really going to advance as a society, because we're too tribalistic in the sense that we want to stake our claim, we want to put our flag in the ground and say this is definitively true, everything else is wrong, et cetera, et cetera. But the weirdest thing, and I was actually thinking about creating my own, podcast and YouTube channel, whatever, and it basically is the name of it is the whole movement of and is you look
Yep.
at the difference between the leftists and the rightists, and you look in the terms of like this is the way we do things, and from a technology and business perspective. Yes, and so I can hold these truths in
Yep.
some semblance of simultaneity, and they can live in coexistence. This and this. I'm a very spiritual
Absolutely.
person. I'm also very scientific.
Yep.
And
Absolutely. You have to. That's part of being holistic, by the way.
yeah,
Absolutely.
exactly. So
Yeah.
the holism is, I think, what if there's anything to be gleaned from the conversation in at large is holism, is really kind of understanding what
Absolutely.
holism actually is, what it looks like. And I would love to come back and talk your ear off again.
For taking the time to explain this. And you've made a really good point of saying it's not just the technology, it's everything behind it. It's the platform, it's the foundational work, both physical and also, I guess you could say, mental or business, if you want to call it this way. So you've done a really good job with that. I want to thank you for being here, Jared, and I certainly look forward to hearing more from you because I love our conversations. And
Likewise.
yeah, yeah, absolutely. Thank you. So we'll see you soon again, I hope.
Yeah, absolutely. And thanks for inviting me, as this is a pleasure.
Absolutely. Thanks, Jared.